So hello my dear students and learners. In the series of data structures and algorithms, in my previous video I have discussed about the concepts of 1D array, and we have also done some programming, for example insertion of a new element into an 1D array, deletion of an existing element from an 1D array, and we have also been familiar that how to deal an 1D array using pointers. Now with this concept we will proceed further. So today we are going to discuss a very important topic that is called 2D array. Now from the name you can easily understand that 2D stands for two dimension. Okay, so two dimension means whenever you are going to define or declare a 2D array, you have to mention two different dimensions. So one dimension is for row and another dimension is for column. So first we will check how to declare a 2D array. So declaration of a 2D array. So I am writing int a 3 4. So here I have declared a 2D array, namely a, and it is an integer type array where two different dimensions I have mentioned, and the first dimension is for row. So this is the row dimension, and the second one is the column dimension. Okay, so this 2D array containing 3 rows and 4 columns. Okay, now this 2D array can also be viewed as a collection of 3 1D arrays. Okay, 3 row means there will be 3 1D array, and each of these 1D array will contain 4 elements. Okay, now 3 rows and 4 columns means this 2D array will contain as a whole 3 4s are 12 elements, and all these 12 elements will be of integer type. Okay, now if we want to assign some elements in this 2D array, we can do it like that. For example, int a 3 4 equals to, now 12 elements we have to mention, so there will be 3 rows, so 1 2 3 4. So this is the first row. Each and every row will contain 4 elements. Okay, 4 columns are there, so 1 2 3 4, this is the first row. Then for example 5 6 7 8, these 4 elements will be of second row, and finally 9 10 11 and 12. So this will be the last row. Okay, so 3 rows are there, and each and every row is containing 4 elements, and all the elements are of integer type. Okay, so this 2D array actually containing 3 4s are 12 elements. Okay, now it can be declared also like that, int a 3 4. So you can mention all the elements like that, 1 2 3 4 5 6 7 8 9 10 11 and 12. So this 2D array can also be viewed like this. That means you can assign all the 12 elements separated by comma. So both the declaration and initializations are fine. Now whenever we are dealing with a 2D array, so the mentioning the column dimension is mandatory, but mentioning the row dimension is optional. So what I want to mean that this declaration is also valid. For example this. Okay, so if we write the same 12 elements here, all the 12 elements here, like what we have done before, so what will happen? This declaration is also valid. Why? Because I have told you that the mentioning the row dimension is optional, so you can mention it or may not mention it, but mentioning the name of the column is mandatory. Now whenever these 12 elements will be there, what will happen? The compiler will divide this number of elements, that is 12, by 4 by column number. So 12 by 4 means 3. So it will assume that there will be 3 rows are there, and each and every row will contain 4 elements. But this type of declaration, for example this one, so all previous 12 elements are there starting from 1 to 12 like this. So this declaration is illegal. Why? Because I have told you that the declaration or mentioning the size of the column is mandatory, so you cannot left it blank. So you have to mention it. You may not mention the column row dimension, but mentioning the column dimension is mandatory. Okay, so these are the declarations of this 2D array. Now what we are going to do, we are going to be familiar with the 2D array with the help of a programming, that how to take the values into an 2D array from user and how to print those values, and we will also check that what will be the memory map of this 2D array. Okay, so let's have the program. So first we have to include the header file, has include stdio.h. Okay, then we will start the main function, that is void main. You have already been familiar that the main is the name of the function from where the program will start its execution, and the return type of the main function is void. That means when this main function will get called, it will not return anything. Okay, not even nothing. Void means it will not return anything. Okay, so first what we have to do, we have to declare the 2D array. So we are declaring the 2D integer array. The name of the array is A. It is of integer type. Suppose it is containing 3 rows and 4 columns. So 3, 4, the 12 elements this 2D array will contain. Okay, and apart from this, since we have to store the values into this 2D array, and as well as after storing the value, we have to retrieve the values. So, and since we are dealing with the 2D array, so we have to track both the rows and columns. And rows and columns index, that means we have to work with the indices of the rows and columns. So for that we are declaring another 2 variable I and j, which will basically track the index of the rows and columns, or a particular rows and columns. Okay, now whenever this line will be executed by the C compiler, what will happen? The compiler will first allocate the memory for this 2D array as well as for the variable I and j. So first then we will check what is the memory map of this 2D array. Okay, so first we will check the memory map. So I have drawn 3 rows and 4 columns. So this is row and these are the columns. Okay, and row and column index will always start from 0. So 3 rows means 0, 1 and 2. These are the index for the row, and column index will always start from 0. So 0, 1, 2, 3. So these are the index for the column. Okay, so now suppose the memory, so 12 elements are there, and suppose a 32-bit compiler, the integer takes 4 bytes of memory. So for 12 elements it will take 48 bytes of memory. Okay, so suppose the allocation is starting from 1001. So this is the, suppose the allocation is starting from 1001. So 48 byte means it will ends at 1048. So the first row will contain containing how many elements? The 4 elements. That means 4 is 16 bytes. That means 1001 to 1016. These 16 bytes will be allocated for the first row. Then second row will start from 1017. So 1017 to 1032. The next 16 bytes will be reserved for the second row. And the third row will start from 1033 and it will last up to 1048. Okay, so the last 16 bytes will be reserved for the third row. Okay, now this 2D array can also be termed as, sometimes it is also termed as a matrix. Okay, so you can check that it looks like a matrix. That means the combination of rows and columns. Okay, now we will draw another memory map where I am going to represent the memory of the each and individual row. So please let's have a look. Okay, so now you can check that this 2D array, the name of the 2D array is A, and I have shown you the memory map in a single row. Actually, although we are dealing with a multidimensional array, 2D array, in a matrix form we have shown this, but actually the elements are stored in these contiguous locations. That is, in a single row the memory will be reserved, the 48 bytes. So the 0th row, that is 0th index row, it is taking 16 bytes of memory, 1001 to 1016. The next 16 byte, that is 1017 to 1033, will be reserved for the first row, and 1033 to 1048, the next 16 bytes is being reserved for the last row, that is the second row. Okay, now whenever you are dealing with a 2D array, if you want to mention the elements of a 2D array, you have to mention the indices of both row and column. So this is the element. Okay, it is present at index 0, 0. Similarly, it will be 0, 1. So like this, all the elements, all the index will be mentioned like that. So whenever you are dealing with a 2D array, if you want to represent any particular element of that array, you have to mention both the indices. So you can check. So this is the element presented row index 0, column index 0. So this is 0 0, this is 0 1, this is 0 2, this is 0 3. Okay, now in the next row it is 1 0, 1 1, 1 2 and 1 3. And for the final row, the row index is 2, but the column index are again starting from 0, so it will be 2 0, then 2 1, then 2 2 and finally 2 3. Okay, so I have mentioned all the indices, pair of indices for row and column here too, for better understanding actually. Okay, now after doing this memory map, what we are going to do? We are going to take the value from the user. Okay, so first we will call the printf statement to print a message on the output screen for the user. So we are calling the printf enter the elements into the 2D array. Enter the elements. Okay, now after that we have to execute a loop. Now since we are dealing with a 2D array, so 2 loops we have to execute. Okay, so the first loop is for I is equals to 0, I less than 3, I plus plus. Now this loop will iterate for what purpose? It is for row. This is for row. Okay, this is command line. You know that this line will not be executed by the C compiler. So you check that here the row 3 rows are there. The row index is varying from 0 to 2. So 0 1 2. So the I value is starting from 0 and we have written I less than 3, that means 0 less than 3, then I will be incremented 1 less than 3, then 2 less than 3. So for index 0, 1 and 2, this loop will iterate 3 times. Okay, then inside this for loop, we have to execute the loop for the column. Okay, so for j is equals to 0, j less than 4, j plus plus. Okay, you check here the column 4 columns are there and the column index is starting from 0 and it ends at 4 minus 1, that is 3. So 0 1 2 3. So here we are starting the value of j is equals to 0. The condition is 0 less than 4. So j will be incremented, then 1 less than 4, 2 less than 4 and 3 less than 4. So for the value of j is equals to 0 1 2 3, for this 4 values of j, the loop will iterate. That means it will take the values for 4 different columns. Okay, so inside this loop, what you have to do? We have to scan the value. So we have to call the scanf function. Now we are going to store the integer value. So that means percentage d is the format specifier. Now we have to write ampersand of aij. Okay. So ampersand of aij means what? First the I value is 0, 0 less than 3, the condition is true, then it will come to the inner loop. J is starting from 0, so j less than 0, the condition is true. So first the value is being scanned for a00. That means whatever value you are scanning, that will be stored in the 00 index here. So suppose we are storing the value 1. Okay, so this is 1. So in this way, the next time what will be the value of j? J will be 1. So then I value is fixed. J will iterate 4 times under the value of I is equals to 0. So I 0 is fixed. Now j will be updated from 0 to 1. Now 1 less than 4 condition is true. So what will happen? Now it will scan the value for 0 1. So suppose the value we are scanning it is 2. So it will be stored at index number 0 1. Okay, so you check 0 1. Okay, now j will be 2 to 2 less than 4, the condition is true. So now value is being scanned for a02. So suppose the value is 3 and it is being stored, and then what will happen? J will again be incremented and it will become 3. So 3 less than 4 condition is still true. Now it will scan the value for a03. Okay, so a03 means this is 0 and this is 3. So suppose this is 4. So this value is being scanned. So we have already scanned the value for the first row. So this is the close of the inner loop. Okay, and this is the close of the outer loop. So this loop is iterating for column. Okay, so now what will happen? The value of I will be incremented. This loop will become false because after taking the value of j is equals to 3, now j will become 4. So 4 less than 4, the condition is false. So we will be out of this inner loop. then it will go to the, but still will remain inside the outer loop, so it will go to this loop, and now the value of I will be incremented, so it will become 1, so 1 less than 3. So now what will happen, the value of I will be fixed, that it will be 1, but j will again start iterating from 0. So 0, 1, 2, 3, for this value it will take first 1 0. Okay, so it will take the value for 1 0, then 1 1, then 1 2, then 1 3. Okay, so this way, suppose it is taking 5 6 7 8, these 4 values it will take for the second row. Okay, now when this loop will again, after taking the value for a1 3, you check, this is a1 3, this is 1 3. Okay, now it will, j value will be incremented from 3 to 4. Now the condition will become false. So what will happen, it will again, the control will be out of this inner loop, but it will go to the inner, it will be out of this inner loop, but it will go to the outer loop. Okay, now in the outer loop what will happen, the previous value of I, that is 1, will now be incremented by 1, so the new value of I will be 2. Now check the condition, so 2 less than 4, the condition is still true, so now the value of I will be 2, that means that we are going to scan the value for the row index 2. Now j will again varying from 0 to 4, 0 to 3 actually, so 2 0 2 1, you check, that is 2 0 2 1 2 2 2 3. So 2 0 2 1 2 2 2 3, for this 4 times the loop will iterate and it will accept 4 values from the user. So suppose the values are 9 10 11 12. Okay, so these are the 4 values it will take. So in this way it will take, and after that, after taking the values for the last row, the I value will become 3, and 3 less than 3, the outer loop condition will become false. So that means we will be out of this outer loop. Okay, that means we have taken all the values in this 2D array, that means 12 elements we have taken. You can take any value, but you have to check that all the values has to be of integer type, because we have declared the array as integer. Now after accepting the value, now it is our responsibility to print those values, to check whether the value that we have supplied has been stored properly or not. So now again we have to print a message in front of user. We will call the printf function. Array elements are as follows. Okay, so now if you want to print the elements, you have to again execute the same loop, the same 2 loops, but instead of calling the scanf function, this time we are going to print the value, so you have to call the printf function. So that is the difference. So we will write the same loop once again. So I am writing this loop once again. For I is equals to 0, I less than 3, I plus plus, and inside this loop we have to iterate the column loop for j is equals to 0, so j less than 3, j plus plus. Okay, now inside the loop what you have to do, you have to just call the printf function. Printf, we are going to print the integer value, so %d. Now if you want to give gap, then you can put here space or tab. Okay, and what you have to print, aij, that means the value present at ith row and jth column. Okay, aij, and that is the end of the inner loop, and that will be the end of the outer loop, and that will be the end of the main function. Okay, so when this program will run, first what will be the output, it will first print this line, that enter the elements. Okay, after this, through this nested for loop, it will scan 12 values. Okay, so suppose these are the 12 values that we have scanned from the user, and then what will happen, this line will be printed. Okay, so it will print that array elements are as follows. Array elements are as follows. Okay, and then it will print all the array elements. Now if you want to print all the array elements in row wise, then after executing this inner for loop, then you have to call the printf function to take a new line. Okay, that means whenever it will go to the next row, then before going to this row, it will take a new line. So your elements will be printed row wise. That means 1 2 3 4, these are the elements for the first row, then 5 6 7 8 second row element, and lastly 9 10 11 12. So the elements will be printed in row wise. Okay, so my dear students, I hope that you have understood the concept of a 2D array, how to declare a 2D array, and how to take the values and how to print those values using both the indices of a 2D array. So thanks for watching. Please take care. Have a nice day.